Okay, I want to look at powers and radicals. And radicals are things like cube roots, square roots, and as we're going to talk about, fourth roots and higher. So let's start with squares, and we've been over this many times. A square, 3 squared, can be thought of as a square, which is 3 by 3. The answer is 9, which can be thought of as the area. And another way to write this expression, an inverse way to write that expression, would be as follows. The square root of 9 is 3. Okay, but we got to be a little bit careful here because there are actually 2 square roots for any positive number. The square roots of 9 would be 3 because 3 squared is 9, but also negative 3 because negative 3 squared is 9. Okay, so the point is that whenever this symbol is used, the square root symbol, this represents the positive square root. Okay, the principal square root. If you go to your calculator and you type in the square root of 9, it's going to say 3, even though there are actually 2 square roots. Alright, the square root of 0 is 0 because 0 squared is 0. The square root of negative 9 is undefined because nothing squared will give negative 9. There is no value. Okay, so in general you can't square root negative numbers. Alright, let's move on to cubes. And 2 cubed can be thought of as a cube, which is 2 units by 2 units by 2 units, has a volume of 8, and the inverse way to write that is as the cube root of 8 equals 2. This entire expression involving the radical symbol, as we call it, is called a radical. The root that we're doing that's tucked into that little position is called the index, and the number we're doing the root of is called the radicand. So the cube root of 0, we ask ourselves what times what times what is 0. That would be 0 because 0 cubed is 0. Let's look at the issue of negatives. Is it possible to take the cube root of negative 8? Is something cubed negative 8? And the answer is yes, negative 2 is. So the answer to this would be negative 2. So as you can see, what's different with cube roots versus square roots is that you are able to have a negative radicand when you're dealing with cube roots. So the cube root of x is possible, we can do it, if x is any real number. Alright, continuing to work our way up the powers, we're at 4th degree now. 2 to the exponent 4 is 16, so we could write index 4, the 4th root of 16 is 2. Now, similar to square roots, 4th roots have 2 answers because 2 to the 4th is 16, but negative 2 to the 4th is also 16. But again, the symbol, the radical symbol here, represents only the positive, or what we call the principal root. Because if you go to the calculator is only able to give you one answer. So if I go to the math menu, here's all my roots, by the way. Cube root there. The xth root would be whatever root I want. So since I want the 4th root, let's go to a blank screen. I'm going to type in my index of 4. And I'm going to go to math, punch in my xth root button of 16, and it even shows it on this calculator, standard way. The calculator can only give me one answer. It gives me the principal root, the positive, even though there are 2. Okay, so let's check out these situations. The 4th root of 0 would be 0, because 0 to the 4th is 0. The 4th root of negative 16. Thinking about that for a moment, it's undefined because nothing to the 4th exponent will be negative, right? Anything to an even exponent will be positive. So in general, the 4th root of x is possible if the radicand is 0 or larger. Alright, and here we are in the world of 5th roots. The 5th root of 32. 5th root of negative 32. Are they possible? And if so, what are their answers? Let's take a moment and we'll go over them. So this would be 2, because 2 to the 5th is 32. Is it possible to have a negative radicand when dealing with fifth roots? Yes, because a negative to an odd exponent is possible. Gives our radicand of negative 32. Alright, just to generalize our findings. So the nth root of x equaling a number means that L to the exponent n has to give me my radicand. Okay, so that's the basic conversion process from a radical over to an exponent. They're connected. N is the index, x is the radicand. Now, whether or not this is possible is dependent upon whether the index is even or odd. If the index is odd, as in our examples above with cube roots and fifth roots, you'll notice that we were always able to get an answer whether the radicand was positive or negative. But when the index was even, as in the case of square roots and fourth roots, we were only able to get an answer if the radicand was 0 or larger. So I can summarize my results as you see below.